Introduces something called flowcharts, which a lot of kids don't love. Essentially, it's a gateway into proofs. And when we prove something, it's important that we have facts and evidence. For instance, if I said, if I was accusing somebody of a crime, it wouldn't be enough to just say, hey, look at them. They look super guilty. I mean, obviously, they did it. You would want to, establish evidence if you could, maybe fingerprints or a video of them performing the crime or witnesses or whatever. The bottom line is you would want some type of evidence. So that's what a flowchart is. A flowchart is going to be something where we give a fact. We say, hey, we know that this is true. And then we're going to give evidence for how we know it's true. And we're going to be able to say undeniably that certain things are true, just like a lawyer would do in a court case. We're going to do the same thing with math. So examine the triangles at right. It says, are these triangles congruent? Well, let's see here. It looks like we have angle side congruence. The 5.75 is across from the 75 degrees in both of them. So I would say yes, I definitely think we have angle side congruence. But now we want to prove this is true. So you can see what's happening here is we're going to say, hey, look, I'm going to give a fact. I know angle A is 32 degrees. How do I know that? Well, it was given to me in the problem. They told me that. I also know that angle T is 32 degrees because that was also given. And I know that means that angle T are the same because that's what congruence means. Congruence means that they have the same. Actually, this should be like reflexive. No, I'm sorry, not reflexive. The transitive property. But we're not going to go into that too much right now. But the bottom line is we know if two things are equal, then they must be equal to each other. The same thing with B is 75 and P is 75. We know that was given, and if they're equal to each other, then those angles must be the same. Could also be substitution, really. And then we know side AC and side TO are 5.75. And again, that means that those are the same. And hey, look, if I prove an angle on a side, it must prove angle side congruence because that side doesn't join those two. So this is what is known as a flowchart, and this is what we're going to be working towards over the next, few lessons. So it says, besides showing your reasoning, a flowchart can be used to organize your work as you determine whether or not triangles are congruent. So let's look at these triangles. So here it looks like they may or may not be congruent. We don't necessarily know by looking at them if they are or not. So we got to kind of do a little bit of work here. If we look, you'll see that they both have a side length of 12. The side length of 12 occurs at an angle that is opposite, hopefully 22.3 degrees, right? So we're not given these third angles here. We're going to have to do a little bit of math, and we're going to have to determine what those angles actually are. So we're going to break out our calculator here. We're going to figure out angle T. We know that angle T is going to equal 180 minus 56.5 minus 101.2. And whatever's left over is what angle T is going to be, and it equals 22.3 degrees. So we'll say that we know that this is 22.3 degrees. And in the same way, we're going to calculate angle G. We know angle G is 180 minus 56.5. By the way, some of you probably already determined. We're going to insert here. Okay. 180 minus 56.5 minus 22.3. And again, some of you guys already went over here and said, well, if this is 56.5 and this is 22.3, this has to be 101.2. And you can see that you would have been right if that's what you were thinking. So there we go. We have all the angles there. So now we say, look, the angles are all the same, which is good. And then we have the side opposite the 101.2. I'm sorry. The side opposite the 22.3 equals 12. So we do either have angle side congruence, or we have angle side angle congruence. Now you can see what they did here is they chose to go with angle side angle. So they must be going the 56.5 and the 101.2, right? They could have done it a different way, but this is the way they chose to do it. So they know that angle C equals 56.5. So which one angles 56.5 over here? Angle P equals 56.5. And how do we know that? Well, we know that because it was given. That's the fact we have. We know that CA equals 12. How do we know that CA equals 12? Well, that's given. And what would make sense today? Well, it would make sense to say PG equals 12 as well. And how do we know that PG equals 12? Well, that was given. That's like a line. PG is what that says there. It doesn't look very good. You'll notice that they didn't really put that line on this one, and they probably should have. So PG equals 12. I do want to say something. You could just as easily call this side GP, right? This is PG or GP. It doesn't matter which one. So they called this CA. They could have just as easily called this AC. It wouldn't have mattered. All right, and then finally, angle G is 101.2. So I guess I want to say angle A is 101.2. But one thing I want to say here. We knew angle A was 101.2 because it was given. We didn't know angle G was 101.2. We had to do math and use the triangle angle sum theorem. So different evidence for these angles. So that's important to consider. Now we know angle C is the same as angle P because that's the definition of congruence. Well, I should be able to say that CA is the same as PG because of congruence. That's PG. And I should be able to say angle A is the same as angle G because of definition of congruence. Again, that's actually not true. It's the transitive property that says if A equals B and B equals C, then A equals C, or substitution. But we're going to just go with what the book says, and they're saying definition of congruence. And then finally, I can make my triangle congruent statement. Again, they're using angle side angle. We proved angle side angle. We proved the side between two angles. We didn't have to. We could have proved angle side, but the book wanted to use angle side angle. So I'll say, it doesn't matter. I'll say triangle CAT is congruent to, well, it must be PIG, but it's not, I don't think, if my memory serves me correct. Angle C is 56.5. Angle P is 56.5. Angle A is 101.2. Angle G is 101.2. So they tricked us here. It looked like they were going to spell cat and pig, but they didn't. And angle T is 22.3, and angle I is 22.3. So there we go. That is CAT is congruent to triangle PGI. And then it says, what's the length of PI? Well, I know that the length of CT is 15, right? The first and the third spot, that line is 15, so the first and the third also must be 15. And this is known as corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. Corresponding parts meaning, hey, look, they're the parts that are across from the 101.2 degrees, right? These are both across from 101.2 degrees, so they're corresponding parts of congruent triangles. We prove these triangles are the same shape and the same size, so that means they have to be the same. So if this is 15, then this is 15 as well. CPCTC is a big deal, especially in integrated 2. A very big deal in integrated 2. All right, I will close this and open up the next one so that we can finish off 713. So there we are, problem 733. To show that two line segments, in this case the side of a triangle, are congruent, matching tick marks are used on the segments. To show that two angles are congruent, matching tick marks are used on a curve of the vertex. Right angles are marked by placing a small square at the vertex or the corner. Refer to the diagrams below. So a couple of things I want to point out. First of all, if they use two ticks, then these are the same. One tick is the same. So if you see a triangle that looks like this, you know it's an isosceles triangle because this side's the same as this. If you see one that looks like this, you know it's an equilateral triangle because all of them are the exact same. So just be aware that if you get something that looks like this, you know that this side and this side go together. this side and this side go together, and this side and this side go together, and that they're all the same. It doesn't matter what they are, they're the same. If this was 5, then this must be 5. If this is 2, then this must be 2. And if this was 4, then this one must be 4. Again, here, if this is 5, well, then they all must be 5. So that's a little bit about the tick marks. The other thing I want to talk about is the angles. The angles work the same way, which is to say, if I do 1 tick versus 2 ticks, that means that this angle here would be the same as this one, or this angle here would be the same as this one. The other thing I want to point out, and this kind of messes kids up a lot, they think that there's some deep meaning to this, but there isn't. You could use bands, like 1 band and 2 band. So this would mean that this angle with 1 band is the same as this angle, and this angle with 2 bands is the same as this one. So if this was 50 degrees, well, then this angle would be 50 degrees because they both have 2 bands. And if this was 20 degrees, well, then this must be 20 degrees because they both have 1 band. So you can either do the ticks, like the arc with the tick, right? 2 ticks or 3 ticks, or you can do 1, 2, or 3 bands. They have the same. As a matter of fact, I saw this as a kid, so I often do these bands and not these ticks, but it doesn't matter. You should be able to go back and forth either way with them. And then again, the last thing is, if it's a right triangle, they'll give you this little box right here, and that'll let you know it's 90 degrees. All right, I don't know how I just closed that, but I did. So let's go here to 734. It says Lindsay was solving a congruent triangle problem and drew the flowchart below. So hey, angle A and angle R are the same, so let's do these triangles. Angle A is the same as angle R, so I'll give 1 band for each. Angle C is the same as angle S. Angle C and angle S. So I'll give, this one I'll do with the tick things. Here I just did a band, but here I did the band with the ticks. And BC is the same as QS. And because of this, we know that these triangles are the same because of triangle congruence, angle, angle, side. That side doesn't match his angle. It says, draw and label the 2 triangles that could represent Lindsay's situation. So here's one way that we could draw that. It says, Marcy was working on a different problem and made the flowchart below. How is Marcy's flowchart different from Lindsay's? Well, this is a big deal. This one says, hey, this angle's the same, and this angle's the same, and this side's the same, so the triangles are the same. This one tells us, hey, look, I know that triangle ACB is the same as triangle RSQ. These triangles are congruent, and because these triangles are congruent, I know that angle A is the same as angle R, I know that angle C is the same as angle S, and I know that side CB is the same as side QS. And this is CPCTC. Again, in B they tell us the triangles are congruent. They tell us the triangles are congruent, so we can say that the corresponding parts are also congruent. Here, we figure out that the parts are congruent so that the triangle is congruent. Again, this one is saying, hey, the parts are congruent, so that means that the triangle is congruent. This is different. This is saying that the triangles are congruent, so that means that the parts must be congruent. It's just the opposite way of looking at it. And again, this is going to be really helpful in Integrated 2 especially.